Okay, we are going to be doing our second Developer's Toolbox talk today, and this one is on root cause analysis and troubleshooting, not specifically as it pertains to programming and software development, but this is going to be more of a general talk. And also for this one, I don't have any like code examples or real world examples. It's basically just going to be a bunch of talking points and then iterate on some processes that we should be following that aren't really necessarily fully documented, or yeah, just basically some tips for how to handle root cause analysis and how to do uh, general troubleshooting, some techniques that tend to work very well for those sorts of things. So there's going to be 5 different questions that we're going to ask ourselves through this root cause analysis process that we're doing. And those 5 questions are very important. So it's if nothing else, hopefully you get that as sort of like the baseline for how you should be doing troubleshooting. So the first question that we have to ask ourselves when we're doing troubleshooting of any kind is why. So why something happened, why something broke, and the first part of that is just understanding the problem, really recognizing what the problem is, and it sounds obvious saying it that way, but really a lot of times when we start troubleshooting, we tend to just kind of dive into things without really taking a step back and thinking through the problem first. So just starting off with understanding what the problem is from a technical perspective and why it's happening, kind of referring back to that first question of why, part of that is understanding what the scope of the problem is. So a lot of times an issue is reported, and the first thing that we kind of have to figure out is what is the scope of the problem, being what users are affected. Is this limited to certain users? Is it limited to certain environments? How much of operations of a service does this problem actually impact? So what's really broken, because that's really going to inform how we address the problem. Not only who is impacted and how deeply they're impacted, but in what way does the problem kind of manifest itself. You're troubleshooting an issue, and a lot of times this does happen. It ends up being like, say, a network issue, for example, but it kind of looks like an application issue from the outside. So you're troubleshooting this application issue when in actuality it's not really an application issue per se, but a network issue. And that's something that maybe even early on you can make a determination about, or at least start gathering some evidence to support that conclusion that is what is wrong. Another kind of aspect of understanding the problem is considering any recent changes that may have caused the problem. And again, this seems kind of obvious, but it's something that often gets overlooked. And the reason why this is so important is because things don't just break for no reason. I've certainly had this conversation with a number of people. The computer is not a magic black box, and same thing at scale with networks. It's not a black box. Devices operate based on instructions that they're given. Now, those instructions may be unclear at times, and if you consider issues with applications written in say unmanaged language like C++ in particular, you've got this concept of undefined behavior. Essentially, in unmanaged languages, things can happen where you're basically giving the computer a list of, or device, whatever it may be, a list of instructions to execute on. And undefined behavior occurs when that stack of execution points to some place in memory that doesn't contain what you expected it to. As an end user, or as a developer even, you may not know what you're telling the computer or device to do, but it's still deterministic behavior. The machine is still doing exactly what you're instructing it to do. It's just you don't know what that is. It just kind of goes back to that whole things don't break for no reason. There's always some kind of cause for something to stop working. That might be that a server got shut off, an application crashed, network configuration changed, something happened that caused that issue. And when a problem starts happening, when something breaks, something goes wrong, the first thing that you really probably want to look at is, did something change that could have caused that to be the case? So another aspect of understanding the problems, and this is something that tends to be kind of difficult to do early on when you're troubleshooting an issue and you're not really sure of all the parameters yet, but there's this whole concept of symptoms of a problem versus cause of a problem. And this is something that you often hear about in the medical industry and in like medical drama shows. The doctors talk about, symptoms versus disease. Like you can treat a symptom that doesn't necessarily fix the underlying problem. And so you have to keep that kind of in mind, just as you're trying to get a grasp of what the problem is, standing whether aspects of that are symptoms of the problem or if it actually might be related to the cause of the problem. Okay, and as we kind of start into this first step of understanding what the problem is, it's very important that we communicate. If you need like input from the team, or if you need additional details from the person who's reporting the issue, it's very important to establish those communications early on, so you don't just let something sit there and fester. First off, it shows that you're actively working on something by communicating. You're kind of demonstrating that, okay, I'm addressing this issue. Just getting that communication started early. Communication is very important even before you have a full understanding of what the problem is. You want to get that going early. At this point, we've kind of taken the first step of not just diving right in, but taking a step back and kind of trying to understand the problem before we get too deep into anything else and doing any kind of root cause analysis. So now at this point, we presumably have some understanding of the problem, even if we don't know all of the parameters, all the things that are causing this issue. We have some idea of what's going on. So now we're ready to ask ourselves the second question, which is why? Why is this happening? Now we're kind of ready to dive in and start taking a look at things. And the first tip here, and this goes along kind of with the first part of understanding the problem, is don't panic. And this is not to say don't have a sense of urgency. If there's some critical issue, we've got an application that's down and customers are impacted by it, the customer's losing money, or it's causing some kind of issue and contention on their side, it's important to show a sense of urgency, which goes back to the communication point, letting them know that hey, we're working on this, we're looking into it. But at the same time, when something is just critically broken, you don't really want to panic and just start throwing things at the wall and seeing what sticks. You really need to take that first step, understand the issue properly first off, and then that needs to inform your information gathering, which is the next thing that we really want to do here. Is now we have an understanding of what the problem is. Let's try and gather some information about what the root cause of the problem might be. Especially with software and network problems, the first thing that you usually want to look at is logs. So applications and systems almost always have some kind of logging. This is text-based messages that get logged somewhere, they get written somewhere. You have to kind of put some thought into, and this can be kind of difficult if it's an application that you're not familiar with, whether it's something that we developed or if it's some kind of external piece of software. We're not really familiar with how it works or what it does, but somewhere that application is logging something. So that could be in a text file somewhere. That could be in, if it's a Windows application, it could be in the event log, which you can access through the event viewer. There's a few different places that you might find logging information. It might be in a database somewhere. Some applications that we have send diagnostic information and an email notification, which isn't really so much a log. But yeah, generally there's some kind of output. 99% of cases, you're going to have logs somewhere that you can look at. And that's the first thing that you want to look at when you're doing information gathering about a problem and trying to figure out what the root cause of that problem is. What do you look for in a log? Timestamping is pretty important, and most logs have some kind of timestamping associated with them. So you've got the date and time that something gets written to a log. That's pretty significant. When did this issue start manifesting? When did it start happening? And you want to make sure you're looking at the right area in your log, the right timestamps, the general vicinity of where you might find messages in that logging that could be helpful. So another thing is a lot of different logging systems have what's called log levels, where you can kind of specify the importance of a message, whether it's informational, a warning, an error. And so when you're troubleshooting an issue, you want to look for those more warning, error, critical kind of messages, because that's usually where you're going to find information about what's going on. We also have, particularly in managed languages, applications that are written against, say, .NET or Java. Most modern languages have some semblance of some idea of a stack trace. The important thing to understand is that I've been talking so far about like issues that come up kind of in production or customer facing issues, but this also applies when you're actually doing development and design and you're doing debugging. I'll also have stack traces and breakpoints and things like that. And these are very useful tools, and it's something that you should be very intimately familiar with what a stack trace provides to you, what the call stack actually is. It seems pretty common sense. It's definitely a skill that most developers do have at least some semblance of, but just the whole idea of this called this called this called this gives you context as to where in the trace you are and what kind of events could have led up to that. And if you're looking at a stack trace in a log or in an email notification or in some place like that, you obviously don't have the capability to dig back through the stack directly and see different values of variables and things like that. You don't have that debugging available to you, but you do have some information that you can derive from a stack trace still in those situations where you can see what called what, and then you can kind of compare that and look at these the line numbers and different functions, look at the source code, and you can kind of see where maybe things went wrong. Another one is reports from users, whether it's something internal, talking to the team, or if it's a customer-facing thing, talking to the customer. It's important to get information about what's going on from the users. It can give you a lot of information about the issue. It just might require a little bit of poking and prodding. And so an important skill to have for root cause analysis is listening and filtering for important information, because where the person reporting the issue is coming from, they may be a non-technical user, and in often cases they are, and so they may not know exactly how to communicate certain information to you or what is important and what's not important. So they might just be spewing a lot of crap, saying a lot of things that, okay, yeah, we know, we're aware there's a problem, and it's really important, though, to sort of listen to what they're saying, making sure that you're actually getting all the information from the user. And then the other piece of that is kind of filtering through the crap and figuring out what has the customer said that is actually relevant to the problem, what might provide us some insight. This one's entirely situational, but also there may be other sources of information outside the scope of logs, stack traces, reports from users, issue reports, things like that. It really depends on the application, the nature of the issue, but there may be other sources of information beyond what users have told you, beyond what you've read in the logs, etc. Again, this all happens before you actually try throwing things at the wall, trying to fix the issue. Before you do any mitigation, you want to make sure that you have all the information that you need in order to apply that mitigation. It's really important that you do all of this kind of upfront. And so you have to think about this before you even dive into anything. Are there any other places where I might be able to find information about this problem? Really, where we go from here, the speed at which you can resolve an issue often is based on some pattern recognition. Like I said in the first part of this, things don't break for no reason. This one really is based largely on experience. As you encounter different types of issues, you will start to generally recognize patterns of behavior applications exhibit, that networks exhibit. And so there becomes kind of, you develop this instinctive element of this looks like a problem that I've seen before. And that only comes with time, but it's really important that to follow these processes because it kind of sticks it in your brain, that pattern that you can recognize whenever additional problems happen in the future. You might see some related things based on what you found while diagnosing this issue. And of course, at this point, you really want to make sure that you communicate what you found in your information gathering. You want to communicate to the team. And so we've got to ask ourselves a third question now, which is why? And what are we going to do from here now that we've got information about the problem? We want to do mitigation at this point. Before we really dive into it, we have to ask ourselves if we have enough information to devise a solution to the problem. We should think about some things like how quickly can the issue be resolved, because that's going to be important for communications. It's going to be important for the management asking questions, things like that. What resources are required to solve the issues? Again, some kind of external resources that can make things go quicker, or if it's a matter of you need to get another team member involved to help solve this based on the information that you've gathered, and effectively communicating that information again to the other resources that are involved, making sure you have basically just everything you need to fix the problem. So you want to be ready to iterate here, not just going back to the drawing board if you don't have enough information for a solution, but also with the solution that you have in mind, you need to think, is there a quicker and easier way to fix this? Is there something that we can do to mitigate that's better than what we initially determined based on our information gathering? Iterating on a plan at this point before you actually start diving in on things is generally a good idea. It depends a lot on the issue. So, and of course, if you don't have enough information, what have we learned from this iteration? What did we learn? We want to make sure that we're continuing to keep in mind the things that we picked up during information gathering. We want to keep derived from communications and such. We want to make sure that we're still keeping that in mind, even though our original idea of how we were going to solve the problem didn't work out. And then we go back to the drawing board with those lessons. At this point, we have a solution, or we thought we had a solution. Turns out it doesn't work. We have to go back. We want to go all the way back to the understanding the problem, really the first step. We want to kind of go all the way back and say, okay, what's the problem here? Did we misunderstand what the issue was? Kind of work our way back through that. And then back to the information gathering. Was the problem that we didn't have enough information about what the problem was? And kind of go back through this again. So basically, if we get to this point, we think we have a solution, turns out it doesn't work. We really need to go back to the beginning of the process and make sure that we're following all the way through. Of course, we want to make sure at this point that we communicate whether we have a solution or not. We want to make sure that we're keeping people in the loop. So it's just another one of those, we need to pause, we need to communicate with the team, we need to communicate with the customer, we need to communicate with the users, whatever the case may be. Fourth question, which is why is this happening? So at this point, we basically want to mitigate the problem. We have our solution, we just put it in place and make sure that it works and make sure that it's addressed the issue. So we act and iterate as needed. And I did put iterate again here because if you put your solution in place and it turns out, well, there was more to the issue than we thought, at this point, we either need to, if we already understand what it is that we missed, we can go ahead and do it. Otherwise, again, we probably want to go back to the beginning of the process and try again to gather information, making sure we understand the problem, that sort of thing. Once our mitigation is in place and it's actually working, we've solved the problem, we need to clear the air. So this is really the biggest communication opportunity, and the most important place at which to communicate is once the problem is solved. We want to make sure that if we've solved the problem, we communicate to our users right away that we solved the problem. And we have to put some consideration into what we communicate to the end user or to the customer. And this can be difficult because in some cases, and this varies a whole lot based on your target audience. In some cases, you may want to omit certain details. And in particular, if you're communicating with a customer who is a non-technical person, you want to give them enough information about what you did to fix the problem without diving really deep into the technical side of it and giving them all the technical detail, because that's just going to confuse everyone. You know, if you're communicating with a non-technical person, it's going to be different than if you're communicating with a technical person. And you'll see this not just in root cause analysis and troubleshooting, but you'll see this, you know, kind of everywhere. Just make sure you understand who it is that you're communicating with and the best way to get the information across. And then, of course, that varies a little bit from internal communication, where what you tell the team, you want to make sure that you're disclosing everything fully, that you're giving all of the technical detail, that everything is being documented in particular. You really want to make sure that we have a solid explanation of what happened and what we did about it. A fifth and final question, which is why. We're going to do a post-mortem after we've fixed the issue, after we've communicated the fix to everyone. Everything's done, everything's closed out, but we want to make sure this kind of reflects back to the first step of when we identified the problem, what really happened, what was the problem. This is kind of redefining the details of the problem as they ended up being truly based on what we had from that first step where we understood the problem. This is just kind of expanding on this. And of course, how did we fix the problem? Could we have done a better job of doing so? These are important questions to ask. If we went down a bad path during troubleshooting, or we took a lot longer on something than we should have, we really have to look at why that happened and see if there's a lesson to be learned there for the future. And that, you know, kind of goes right into the next part here. What have we learned, and can we make any process improvements? We want to make sure that not only could we have fixed this issue more effectively, but is there something that we could have done for prevention? What could we have done to stop this from happening in the first place? And are there any process changes that we need to make to make that happen? So I'm all for kind of feedback at this step. You may have noticed that the 5 questions that we asked ourselves while we were troubleshooting are all really the same question. That's why, and it's important to iterate on that question. It's funny. This is actually not a concept that I came up with. It's a really kind of an industry standard thing, and it came up recently in a podcast I was listening to. It was mentioned by one of the hosts of the podcast that you should ask yourself why 5 times whenever you are doing root cause analysis or troubleshooting, because the first why, chances are you're going to get kind of a superficial answer. Why did this happen? Well, because the connection to the database broke. Okay, great. So we fixed that. But why did the connection to the database break? Well, see, what had happened was, it's really important to iterate multiple times and get down to the very bottom of things, because that's what root cause analysis is all about, is actually getting to the root cause and not just addressing symptoms of a problem or addressing a problem upstream that's actually caused by something else downstream.